Hello everyone, today's lesson is on equilateral and isosceles triangles, and the essential question is what relationships between sides and angles of triangles can be used to prove triangles are congruent. The criteria of success is I can solve for all sides and all angles in an isosceles triangle, and I can solve for all sides and angles in an equilateral triangle. Alright, today's concept isn't too bad. Alright, we are looking at triangles, two different ones. The first one, equilateral triangles. Equilateral triangles have all congruent sides and all congruent angles. So in the inside, we have three congruent angles. And if you know that they all should add up to 180 degrees, then we can conclude that these come out to be 260 degrees each, okay? So if it's not labeled in a problem, right, and it says it's an equilateral triangle, or you see matching notches, you can say that each of these would be 60 degrees. As far as the sides, if they're not given, we can't tell for sure, but if one is given, let's say that B is like 5 units, then we can conclude that the rest of them should be 5. Okay? Alright, so these are equilateral triangles. Now, isosceles triangles, we have just two congruent sides or two congruent angles. Okay? And if we are given an isosceles triangle with two congruent sides, then we can assume that the angles across from the sides will also be congruent. So here in the blue, those two are congruent. And if we do the reverse, the converse of this, then the sides must be congruent, okay? All right, I'm just going to guide you to a few example problems. And afterwards, you'll have some collaborative work time to apply all these concepts, okay? So, equilateral and isosceles triangles, we're going to use the properties of equilateral triangles for these two problems. All right, so we talked about how equilateral triangles have congruent sides. We can label that here, here, and here. And if we're looking for the value of x, right, we can set these two equal to each other, or these two equal to each other, or these two equal to each other. Now what makes sense if we're solving for x is to use only one variable. So really, if we set this one equal to this, we end up with x equals 10, okay? Which is done. It's already done there. X is equal to 10. Okay? And so, in order to find y, we can set this equal to 10 or this equal to 10. There, it doesn't matter. We'll be able to solve for the y variable after that. So if you do y plus 3 is equal to 10, it's a one-step equation. We can subtract 3 on both sides, and y comes out to be 7. Alright, so there you have it. X is equal to 10, and y is equal to 7. So that's what happens when we apply this to the sides, congruent sides. Now, if we apply this to angles, right, it'll be slightly different. I remember that what we set up here is all the interior angles should be congruent, and they should all be equal to 60. So this is equal to 60, this is equal to 60, and this one should be equal to 62. And so you can set this up as it looks like. We have y minus 8 is equal to 60 degrees. And then if we solve for y, we can add 8 on both sides. So y comes out to be 68. Not degrees, because it's a value. But after you plug it in, 60 minus 8 should be equal to 60. So y is equal to 68. All right, if you end up having any questions on equilateral triangles, you can write them down here, and I'll address them when I come back on Thursday. So these are pretty much properties of equilateral triangles, and we talk about congruent sides or congruent angles. Okay, just keep that in mind if you're trying to solve for any of these. All right, so now let's talk about isosceles triangles. All right, in problems like this, we need to identify which of the angles are congruent based on what we are given, or which of the sides are congruent. Okay, so if we're looking to find the length of both sides of ABC for this one, we need to establish that two of these will be congruent. And we can determine that if we take a look at what we have labeled here. We have the angle here and here, and the angle across will be the side that is going to be congruent, and then the side across this one would be congruent. So we're looking at these two with the notches in the red are to be congruent, so we can set them equal to each other. We have 3x plus 4 is equal to 10. Okay, and so if we solve for x, then we'll be able to solve for all the sides when we plug them in. So apply inverse operations. It's a two-step equation here. We have 3x is equal to 6, and then divide by 2. Then we end up with, or by 3. We end up with x is equal to 2. Okay. So we can use this value of 2 and plug it into this one to find the length of AB. So AB is going to be 2 plus 3. So this comes out to be 5. Okay. AB is equal to 5. And then for AC, you can do 3 times 2 plus 4. So this is 3 and 2, 6 plus 4 is equal to 10. All right, which makes sense because that's what it has to be congruent to this. So AC is equal to 10. Okay. All right, if you have questions, again, you can use the side here. Jot them down and I'll address them when I come back. All right, and then this last one here, we're looking for the value of x, okay? And I know how the problem is set up right now. You may be tempted to set these equal to each other, but that's not the case because we haven't determined which of these angles will be congruent. If we take a look at what's labeled here, here's the notch, right? And the angle across the notch would be this one right here. Correct? And so the angle across from this one would be that one right there. All right, that doesn't tell us much yet, but what it does allow us to do is to label this one as 3x minus 2, okay? And now if we add all of these interior angles, they should add up to 180 degrees. And so we can take all of these pieces, like 9x plus 4 plus 3x minus 2 plus 3x minus 2 repeated, and set that out equal to 180 degrees, okay? So that would be the relationship. The sum of interior angles is equal to 180. Then we collect all the like terms. So we have 9x, 3x, and 3x. If we add those together, we end up with 15x. And then the 4 and the 2 and the 2. It's actually going to cancel out 4 minus 2 minus 2. Okay? So we cancel that out. And that's is equal to 180 degrees. And if we divide both sides by 15, then x will be 180 degrees divided by 15, which comes out to be 12. So x is equal to 12. Okay? Alright, if you have questions, you can jot them down in the left column. Alright, I think that's pretty much it. Those are all the only two types of triangles we're looking at today. And these are the concepts. We're either setting things equal to each other based on congruency, and the angles or the sides depending on the triangle. Or we always have the option of setting things equal to 180 if we're looking at the interior angles. Okay, so I'll have an answer key for you so you can check your work. If you have questions, you can ask the substitute teacher, which he'll have an answer key for you. So we have problems like look like this: equilateral triangles, follow the notches. We have isosceles triangles here. And then we have some more challenging problems with an equilateral and isosceles together. So two isosceles here, and then isosceles being bisected there. All right. Don't forget that you'll be taking your quiz today in the last about 15 minutes of class. Other than that, you save any questions you have for me until Thursday.